This one represents the first in the series of planar figures. And this one represents the ultimate. This one sets the pattern going. That's sharp, eh? And in Latin, we call that acute.
Oh.
An acute angle is a sharp angle. And this is a triangle. And it's rather lovely. It has 3 angles there. 3. Can you imagine a figure with only 2 angles? With only 2? No, this is the beginning of the series of planar figures because it has 3. 3 is the smallest we can have in a 2-dimensional universe. Yes? In a 3-dimensional universe, we need 4. Okay. So?
The plane, what?
Planar. P-L-A-N-A-R. Or just plane figures is fine. Planar. This little guy doesn't hurt anywhere near as much, don't worry. Does it? I'm going to giggle that one.
Do my other shoulder.
Doesn't hurt as much? Right, this is a right angle. Beautiful. Your eye recognises right angles. You know how you can tell when the picture isn't quite straight? Your eye has an understanding of straight and across. In fact, there are little parts to your eye. It's really cool. It will recognise a circle. It'll fire when you see a circle. A baby, when it sees a circle, gets very, very excited. You know, 2 or 3 minutes old baby will get really excited. Already recognises a circle. That's pre-done because baby looks up and sees mum's eyes, which for the baby are circles. They're not the parabolas, but it doesn't really matter to the child. Okay, right? Cool. So those circles are pre-in and up and down, and orthogonal lines are in there. That's why the square is so important. You'll like this one. It's okay. This one has infinite points and pro. This one is infinitely smooth. Okay? These are obtuse, and no, this angle here is almost flat. Okay? It's almost a straight angle. Yeah? It's quite smooth?
Yeah.
You see why I did it now?
Yeah.
Yeah. I just come and did this, so you think it's odd. Whereas if I poked you with a triangle first, you think that's normal.
Yeah.
Normal is very relative. Triangulos. The Greek word for knee is angelos. And so this has 3 knees. You can see tri being the word for 3. The square is the Latin word for square, which is where we get the square idea from. This idea of intersecting parallel lines forming this plane here. This dude here, circle, cirkulos, meaning ring. It's a ring. Rather lovely. Okay? You now know all of those names? Jolly. I'm going to introduce you to the rest of the geometry cabinet. There are just 100 ways I could do it. I'll do it this way. Antonina. Five.
Pentagram.
Pentagon
Pentagon.
meaning? Penta.
5.
Gonia meaning? Triagon.
Oh,
Triangle.
5 knees.
5 knees. Hexagon.
Sip.
Hept is more
Oh,
useful
hept.
in New Zealand English. Heptagon. We don't often use septagon. We use heptagon.
Octagon.
8, because it's an octopus.
It isn't an octopus.
Well, no, but you know.
Octopus have 8 legs.
It is okay.
Octo, yeah, you're right.
Yeah.
9,
Decagon.
8, 9.
Decurion.
Nanogon.
Decagon.
Decagon.
Decagon. Choice.
What was 9?
Nonagon.
Nono.
Nonagon.
Who's gone? You're gone.
I want to offer you an experience of calculus. Did anyone do calculus at school?
No.
Yes? You just need to see this. Maybe I'll put that. And this circle fits perfectly into its frame, correct? There's no more stabbing. Well, there's a little bit more stabbing. But not immediately. What's this one? What's colour's this?
Yellow.
That's all good.
Because the sun shines on it.
If I take a pentagon and inscribe it into a circle, can you see that there is a pretty good fit, although there's a bit of gap in there. There's a little bit of gap, right? So that we could work out that this pentagon sort of fits the circle, bit of a gap. Is the gap going to get smaller or bigger when I move up to a hexagon? Smaller or bigger?
Smaller.
Smaller? You reckon smaller? These things are falling apart, which is sad. I'm going to put in the next in the series. Can you see the gap? There are more gaps, but each gap is a bit smaller. What about here? Smaller or bigger? This has got 7 sides. We've got more sides. Smaller or bigger?
Smaller.
Pretty convinced of that? Woo! Nice. Lots more gaps, but each one is smaller. Smaller or bigger?
Smaller.
Tiny little gaps, yeah? You'd almost get away with that, wouldn't you? Let's have a look at this dude. What are we up to? Nonagon.
Ooh. We gotta get
More
up.
necessary.
It's pretty close, isn't
These are
it?
gaps.
Now, because this is a 10-sided, let's whack her in.
So
But let's say I've run out on my tray. Let's say I had another tray and it took me up to a 50-sided. Put in a 50-sided. Will there still be gaps?
Yeah.
But less and less, right? Less and less and less. So actually, I could take another tray out. This one's got 5,000 sides. This is why we need to understand 5,000, because it's a good way of us understanding imagination, right? 5,000 sides. I pop it in here.
tiny, tiny, tiny.
Tiny gaps, but still they're there. You know they're there, right? This one on this tray down here is 655 billion sides. Still some gaps?
Yeah.
And if I keep on going forever and ever and ever, there will still be gaps.
Infinite.
But our understanding of circle is that there are infinite sides. Infinite number of sides, each of which is infinitely small. There's the concept of limit, by the way. If you needed, somebody asked me what an asymptote is the other day. This is our concept of limit. Right here in the 3 to 6 material, you guys see this, you see all of this, you don't go into quite this detail, but you'll know that in here we have the concept of a limit. Can you see why I say now that the triangle is the first in the planar series, and the circle is the ultimate of that series? The circle is just a triangle grown up. Grown up. Yeah. That's rather sweet, isn't it? That all of these guys fit together. Now yesterday, you were actually playing with some material that helps you to explore that. Whose number is 5?
Alicia's was.
Which is 5? And who was 4? Who did 4 yesterday? Can you see that when I place this, like this, I create a 5-sided shape called a pentagon. Because it's a regular shape, we can call it a regular pentagon. All the lengths are the same size. What happens when I've got a 4?
Square.
And what will this shape be called?
Hip.
Pretty wild, eh? Okay? So we were blah, blah, blah maths yesterday, but now I'm blah, blah, blah. These are geometry. These are an example of geometry. Yes?
My goodness.
Yes?